Alright, so the main thing about this, the main trick, that we have this elliptical on its side, and while it's still gonna be looking like any of these ellipticals and any of these ones, the tricky part is to find the angle at which the center of that elliptical will be. Okay, because this center of the elliptical over here is not part of any of the lines we are normally drawing when we are drawing it as a cylinder fitting into a rectangular prism. Okay, that's why there is this little angle drawn and there is this little line, you see? So that's the little nuance. All right, so I suggest again to start with the horizon line. Let's just have our horizon line like right near the top here. So it's nice and straight and horizontal. And so if your cylinder, like in the book, if you're doing this, it's better to position it here, obviously, right? More on the side of the page, which means that we are going to be having our vanishing point here somewhere, and we'll create our rectangular prism right in here, and then we'll fit all the elliptical shapes into it, right? So let me do this. I'll use the red one for just the rectangular prism first. That is fairly easy, so I will even just start with the vanishing point, just so that I could plain say, like, where can my prism be? Why is it sagging? Don't sag. Where can my prism be? That it will connect within my page to the vanishing point, right? So for example, we can do something like this. Obviously in the other direction, it may or may not fit to the vanishing point. So let's see, if I were to say, okay, what if I do something like this, right? Then this will be my rectangular prism. We can even like project it more like this, and we can say like, okay, if this is like the back, this will come over here, then it will be something like this, and like that, right? It's fairly reasonable, right? But do we need to do that exactly? Not necessarily, right? Because it's going to give us very strong angles. See how much stronger this angle is compared to this one. And so that means that once we construct our prism, you know, more like that, our cylindrical shape is going to be right in here, and it's going to be pretty strong and not necessarily what we deal with in everyday life because of the strength of the angles. It's more like building size. In everyday life, this would be on the scale of the city and so on. So let's not go to this extreme. We'll just use everything in this direction, and we'll say, so our rectangular prism would be here. We'll construct it with a reasonable angles, and then we'll connect it to everything else. So let's say that, again, it's a bit saggy here. All right, that's close enough. Let's bring one of the sides here. Let's say this will be one of the vertical sides then. So now I guess it's a good enough size. I'll draw it kind of large so that you could see everything more or less easily, right? So in this direction, I will go at a milder angle. So obviously it's a long way to the vanishing point, right? But let's just make sure that this looks more or less like a rectangular prism. And how do we do that? If, let's say, if this is the height of our prism, right? And we're doing like more or less imaginary one, and we compare it to here. Since this is at an angle, slightly foreshortened, it can't be the same measurement, right? It has to be shorter. So we'll take this, compared to that. Already I've gotten kind of shorter, so I'll say this will be good enough for me. So this will be my vertical side. Okay. Nice and good intersection here. And so now we have to figure out how we're going to go in this direction so that there is that perspective feeling, right, where it's getting closer and closer. So if I sketch in this line, and again I will measure this size, and I'll compare it to near the edge, it's getting closer. So because we're getting closer in this direction, very gently, very mild foreshortening, because we're seeing quite a bit of this side. Here's our exact flagged horizontal line to compare to. This is a very mild angle, so foreshortening is not very strong. And so I would say that just from experience and from looking at it, you look at it and you go, I guess it looks good enough. Plausible, right? I don't like how it's starting to bow in here. No bowing. Okay. This will work. So this is our one side. And we have it according to our rules of perspective already constructed. All right, so then all we have to do is now connect this to our vanishing point, obviously. Okay, that's pretty close. Okay, you're connected. This still has a little bit of a dipping in here, it bugs me. Let's not dip. Now it's wavy. Okay, you got the general idea. And so now this can be constructed as well, right? But let's just go ahead and establish where the back of our prism is going to be. Let's not go too far. And we'll say like, okay, if this is our angle, if we bring it here, it just needs to drop a bit, right? Looks like I'm already dropping it a bit. So let's see. If I drew it in a more or less straight line, how is our foreshortening? So for example, let's compare it. I didn't draw it in this direction yet, but it will be good enough if we compare it from this point up here, from this point up here, quite a bit, right? So it's coming down, and that's good. So not only this is coming down, this is coming down. So let's construct this one to the vanishing point. Too high, a bit lower, almost. right? Somewhere in between all of these lines, we got ourselves more or less straight one. All right, so in that case, we can drop a straight line through here and form that back, right? And then we can drop a straight line through here and form that back. So the back wall is starting to form. Here it's going to be one elliptical shape for the cylinder. Here it's going to be the other. Now we need to get it going in this direction correctly. So let's compare now how this is going to go. I will just kind of guess. I'll guess. Will it be good enough, right? Will it be enough of the kind of foreshortening we're looking at? So first let's connect this and measure it, and we'll compare it to this already getting shorter. And if we can compare it from this point to this line, it is, and here it's even more. So this distance, so this one seems to be doing well, right? Seems to be not too extreme. It's not dropping too fast. It's not like dropping too fast. It's not staying too parallel to this line. And so overall it fits. And so if we go ahead and do the same thing over here, because that initial line I put in seems like very close to what we need. So you see how they all fit nicely in between, right? So here there is a nice gradation. They don't seem to be getting too close together. If you got this angle wrong, by the time you get here, it will look too out of whack. If you get it wrong this way, by the time you get here, it will look too out of whack. As long as they all seem to be getting close, kind of at an even interval, right? You're good. So now let's see if we got everything right. We connect this again. And if we connect this, and we connect it to the vanishing point, then the rectangle is there. The prism is correct. Everything seems to be connecting pretty well. Okay, I'm not too worried about the straightness of these lines in terms of like, they just need to be straight on average. If they go a little wobbly here and there, it doesn't matter as long as they are. As long as if I took a straight ruler and this point went, the ruler went through from here through this point and arrived in here, it's fine, right? So the most important thing is our connection points. Okay, so it was a quick recap on how to construct a rectangular prism on its side. You've done cube before. This is just a longer cube, rectangular prism. All right, so we got that. Within this, we need to find our half because we're doing the slices, right? So here's the rectangular prism. We need to position this half slice. Remember how we found how to find the center when it's foreshortened? You remember how?
We take any one of these lines and find halfway through.
So like from here to here, we can like measure it halfway through and then move it off slightly for the foreshortening, right?
Yeah.
Right. But there's also a sure way to find it. So for example, now this is a little longer than this, right? So you can kind of guess and say like maybe this is where it is. But a more sure way is to connect our corners, right?
Oh, right. We can do an X even when it's a rectangle.
Exactly.
Ah.
Foreshortened rectangle. Let me see. About like that. A little higher here. All right, so there we go. How is that looking from the distance? Right? So it seems like right here is your center, right? So now if we draw a line that is fitting in between these two, so again, it's preserving that angle and the lines getting closer together, just at the right rate. Just at the right rate. This is not very straight, it's more like over here. Okay, so you see, now we found a true center for this angle and this foreshortening. Yeah, probably better be a bit higher here. All right. So here's our intersection. It means we drop the line here. So the foreshortening is even stronger. And it is stronger than we guessed originally, not because we're guessing wrong, but because we are fitting it to this much stronger foreshortening than what we're used to seeing in everyday life, right? So it is a much stronger foreshortening because, again, it's like the scale of it in reality would only be closer to a building size. It doesn't matter. The scale, proportions, and rules work the same. So, okay, so this is our straight line. Drop it down. Everything is nice and parallel to each other. And so here we go. Same thing on the back. And remember what is happening, that while in this direction, as this object moves, this becomes less and less visible as it moves to align with a straight line from the vanishing point, right? This is moving away, and so we're seeing more of this back wall. Remember that, right? So because of that, we have this distance wider than this. And it's totally normal. Do not get confused. Not everything shrinks with perspective. Some things open up. All right, so now let's see. If we constructed this correctly, then when I connect this two and project it into the distance as a straight line, it should fit right in. Seems like it fits nice. I'll keep that. All right. So here we go. So this is our rectangular side. There we go, better. This is our slice. Oh, I had it better before. Shouldn't have touched it. All right. So here we go. We got everything. Pretty much visible. Let's make this a little darker, more sure. This one is all right. So now what do we do? Now we find the rotational center that goes this way. Actually, the other rotational center is here. In a way, you can rotate the whole thing and it will be completely balanced because it goes through the center. But now let's get the rotational center. That will be our center for the cylinder, right? So again, we connect the two corners Just need to make sure it's nice and straight. If it's sagging here, your center will be off. That's why it's important not to let these lines sag in any way. See, that's no good. This is better. Okay, now let's distill a nice and straight one out of this. Okay. Okay, that's better. All right, I like that. I'll keep that. This is our intersection. Same thing is done on the back, and technically you can do the same thing here. All right. That's closer to what we need. Okay. All right. How we're gonna double check is we're gonna check this and this. That's what I suspect. It was a bit higher than what I need because we need it on the exact center. You see? That means that probably this one is just curving a bit too much. So let's make sure we hit it lower here. And we hit it lower here. Ah, we're good, we're good. Keep that, right? Okay. So technically we now can just connect it and we're done. But for the heck of it, let's do this one as well. Fairly straight. Okay. Okay. Here I won't sweat too much because once this starts connecting and going through the center, if it's not right, it won't look right, right? Just let's check. Close enough. So it should be fine. So now we can connect. Let's see if we just connect this and then we connect this. Does it look straight? Almost, no, kind of iffy over here. It should be also fitting within our other lines and heading right for the vanishing point, right? So technically it also has to go over here to our vanishing point. Okay? If it doesn't look like it's close, if it's definitely not going toward the vanishing point, then you know you got something wrong. Something's off. Okay? So what I'll do is I will actually, oh, this is a good green. I will now change it to green color. There we go. This is our rotational center. Everything's good. So now we can move on to constructing our ellipticals, right? See how here it's a bit, ended up being a bit lower. There we go. That's a bit better. Okay. So we now can start working on our ellipticals. I'll still use green. For elliptical, see how this angle is not 90 degrees to the center. And that is an issue because when we're doing the vertical, right, elliptical for the vertical cylinder, it's 90-degree angle. No matter how open it is, whether we're looking more down or less, it's always 90-degree angle. This is not 90-degree. Therefore, we can't just construct our elliptical to fit in here based on this line. So what we need to do is we need to draw ourselves a line that is going to be 90-degree to the rotational center, and that's the tricky part, right? That's the knowledge you have to have, otherwise the drawing is not going to come out right. So I'm even tilting my head to see, like, is this 90-degree? Does it look like 90-degree? And so this is my guess, right? Now I'm just going to take one of my tools and see, like, all right, that's close between these two lines. And here it's getting close, right? So definitely not this one. And something in between these two. Pretty much, if you tilt your head sideways like this, you can see if it's 90-degree, if it's close. All right, so let's see. This is more or less straight. More or less straight. As long as it's 90-degree and it's a straight line, we're good. All right, so now we converted this. We got ourselves a 90-degree angle. And now, because of that, we can start constructing the ellipticals of the cylinder. Same thing is going to be happening back here. So again, look at it, see, like, is this a little too strong? Okay, now this thing misbehaves. Here's the thing. This and this are pretty much parallel. If this is 90-degree to here, then, you know, it's plane geometry. It doesn't change based on how far away it is. Wait, I'm not quite going through the center here. This is now close enough. Okay. restore what got erased a bit. All right. So now we have 90-degree angle here, right? And the same thing is going to be happening here. So basically, this is parallel to this, is parallel to this. Got to go right through the center. All right, so for example, you can see that my angles here are a bit more extreme than in the book, right? Here, see how tiny that line just veers off just a little bit. I have a stronger, it's because I got that stronger perspective. So for the sake of demo, it's good. So you really get to visualize the rule and you can focus on what's going on, right? For example, if you are standing back here, I'm standing back here and I'm seeing that this is not quite parallel. This is like leaning a bit, so I'm going to straighten it out now. Let's see. Yeah, if I do it this way, it's better. So the more accurate it is, the easier your job with the ellipticals becomes later. All right, this is better. Still can straighten it out more. More this way. That's good. See how far I've come just by comparing it to the first one. All right, that's better. And this, let's get rid of that. It's messing with our geometry. And that. Okay, now it's a ton better. Okay. So now we're basically ready to start forming these ellipticals here, right? The elliptical shape, the top circle of the cylinder, cannot go beyond any of these boundaries, and it has to come through here. Remember, just like on the vertical ones, right? This is our sides of the cylinder, our sides of the cylinder. Well, not exactly, but we will find them based on how we're going to start working on the elliptical. It's going to come up a bit. So here's coming up quite a bit because it's very close to the angle. We don't have it so close. But we do know, sorry, that it cannot come past this here, which is also one of our centers, right? Let me see. I'll take the green again. So in the foreshortened way, we can figure out where the sides of our rectangular prism are. And if we draw a straight line here, we know this is the other center, right? So slightly more, slightly less, as long as they're all parallel. So imagine that a cylinder is fitting into this box now, right? Where would the sides be? The sides would definitely be touching on here, right? Because it's only laying on its side compared to how it's standing. Some sides are always touching through the center of this box, right? You understand? Not much different than how it was here, right? Here's the center of the box of the prism. Here's the side of the prism. The elliptical is touching on its side. So it has to come through here. But it's already starting at left off, right? It has to come through here. It has to come through here. It has to come through here, right? Then somewhere in here, it's going to be not exactly this distance, but not exactly as long as that either, right? It's going to be something in between because it's not a perfect circle. So it's going to be shorter than this side, which is the true height, the true measurement, because it doesn't get foreshortened, not at this level. See, it's a little bit longer than that. This is the one that gets foreshortened, this line, this distance, this side of the prism. But this one is going to be something in between, right? So it's not going to be as tall as that. It's not going to be as short as that. So it's going to be something in between. Just in between, we'll guess right now, right? So the same thing is going to happen with the others, basically. What you need to do is now, once you're doing this elliptical, focus on how it's going to hit this and this line. It's not going to be as all the way down to the side, and it's not going to be all the way up either. But if you were to turn the whole thing on its side and make it vertical sitting on this line, it should look like a normal elliptical shape. Okay? That's the tricky part. But there is no other way to, like, for us to calculate it where it's going to be. All right? So let's just approximately look at this. Put this like somewhere in here. That's about the same size. I won't go into too much measuring. I'll just throw this in first. It's like first kind of guessing. Here it has to start getting a little longer. And here's where it intersects that. Okay? So now we're gonna do approximately the same thing in here. And the same thing in here. Julie? Okay, so look how it still is not a good shape. It's just an approximately, so we could start squishing it into what it should look like, right? It should look nice, elliptical, no problems, no issues type of shape. So what do you see? Like if this is our center, you see that here perhaps it's kind of all right, right? Because now we're looking at it and we're comparing it as these two sides, side by side, right? Two halves. Try and imagine it that you're comparing it. Has to come through here. Has to go through here, but it doesn't have to be that long, that deep. Has to do a touch down here. And it has to look symmetrical with a teeny bit of foreshortening on the other side, right? Has to touch down through this, not that other one. Oh wait, no, this is the back side, through here. It has to touch down through here. And then on the other side, basically we're doing the same thing. So this is a bit too far. Don't get too crazy over here. So I'm cleaning it up so you can start seeing the more true shape of what we are shooting for, right? This is our intersection, so a temporary short touchdown, and then it starts lifting off, right? All right. Perfected, perfected, perfected. How's that? So, and again, you imagine that these are the two halves based on this center, right? So it's pretty close without getting too like super pooper into it. You can polish it up when you're like doing your drawing. But this is now carries the right idea. It's close enough for our lesson explanation. Fits into the box, into this side. Therefore, it fits into the entire box. Same thing needs to be constructed here and through the center, right? And then we'll have that other slice, this other plane through the center, right? Based on these sides, which, by the way, also because it's going right through the center here, it's going to be connecting to this vanishing point in the other direction to the other vanishing point, right? Did you want me to go ahead and do the construction of the ones on the back, or do you pretty much get the idea?
I think I get the idea.
Okay, I'll just do stop motion and finish.